Okay, welcome everybody to this introduction to Micronaut talk. My name is Graeme Rocher, for those who don't know who I am. I created a framework called Grails. Any of you familiar with Grails? A few hands. I created a new framework, which I'm talking about today, called Micronaut. I wrote a couple of books. I used to work for Spring Source, then VMware, then Pivotal in that little journey. I'm now a senior engineer at Object Computing. This year I was lucky enough to be chosen for the Oracle Groundbreaker Award at Oracle Code 1. I felt a little bit out of place next to the creator of Python and the creator of Kafka and whatever, but it was an honor to be there amongst amazing people, so thank you to Oracle for that. So in terms of what we're going to talk about today, we're going to talk about how we got to the framework space in terms of Java and microservices, microservice challenges, microservice framework landscape, and then we're going to do some Micronaut demos, loads of demos, mainly demos. So if we look at then and now, 10 years ago when Grails 1.0 was out, when I was working on the Grails, and it was a very different technological landscape and a very different landscape in general. Everybody was building monoliths back then. Typically, you didn't have the maturity of the JavaScript front-end frameworks that you do today. There was no Angular, there was no React. Things like Docker didn't exist. Microservices wasn't really formalized as a concept. So certainly things have changed a lot in the last 10 years. And in that time, I think the Java industry, we've tried to adapt existing, essentially legacy technologies for microservices. And the reality is that, if you look at technologies like Spring and Jakarta-E and so forth, they weren't designed at the time when microservices were designed. They were never really optimized for low memory footprint microservices. So when we looked at this problem a year ago and we just thinking about what to do, we had a kind of decision in our minds where, in terms of a framework like Grails or Spring or whatever, you can kind of either try to convince people that something that's never designed for microservices is still okay, or you can go back to the drawing board. And that's exactly what we did with Micronaut. So the goal with Micronaut was to create a new microservices framework designed from the ground up with microservice and serverless computing in mind. So coming from a clean slate and looking at the problem from a completely different perspective. So the things we were prioritizing were things like ultra-fast startup time, a very low memory footprint, as small as possible jar file sizes, very few or little to no external dependencies, making sure the application was 12-factor. These are the kind of considerations we had in mind in our design. But before we started, we kind of did an analysis of Spring and Grails and challenges to using them to develop truly micro applications in terms of memory consumption, startup time, and so forth. And what we found is that, Spring, and the same applies to Jakarta-E and any framework that uses runtime analysis, reflection, etc. They're amazing technical achievements, and they do a hell of a lot for you as a developer, but they do everything at runtime. If you look at the Spring source code, it does things like it reads the bytecode of every class, every bean in your application context, because it needs to know the annotation metadata. So it reads this annotation metadata directly from your .class files, and it synthesizes new annotations which are like a mirror of the actual annotations for each bean, constructor, field to support this annotation metadata. It also builds reflective metadata. So for every single bean, injection point, etc. in your code base, it builds this reflective data. And what the problem with this approach is that as your application grows in size, there's a correlation between the size of your code base, the number of beans that you have in your application, and the memory consumption and startup time. So more code, the more work Spring has to do. The deeper your inheritance hierarchy, the more Spring has to, and Jakarta EE is the same, has to go in and analyze the inheritance hierarchy, traverse reflectively up your superclasses, analyze your whole code base at runtime, right? So what you have, and a lot of people have realized this, so what you have if you look at the overall sort of framework landscape, you have kind of a division in what frameworks are out there for developers. You have on one side the kind of opinionated frameworks that developers really like and provide a lot of features out of the box. Spring Boot, Grails, MicroProfile and Jakarta EE in this box. Generally annotation driven, very popular because people love the out-of-the-box features. And then the other side of the spectrum, you've got the low memory consumption and startup time frameworks that I would categorize as like do-it-yourself frameworks. Now these frameworks are fantastic. Vertex is a phenomenal framework, in my opinion. It's really well thought out and a nice toolkit if you want to get really low level and get the ultimate scalability out of your application. Vertex is really cool. And they're interesting frameworks, but they're very much do-it-yourself, wiring together your components, figuring out how to integrate them with data access. There's no AOP, no dependency injection. The typical patterns that developers are comfortable with from frameworks like Spring and Jakarta EE are not there. So you've left with this choice of basically either choosing one or the other, the low memory consumption and startup time, or the high memory consumption and startup time with more features. And frankly, we thought, why does it have to be this way? Because the reality is that any framework based on reflection and the runtime analysis of annotations becomes fat really quickly. And why? Because essentially these frameworks like this, they have to perform all of this work at runtime. And there's an irreconcilable conflict, tension between trying to achieve fast startup time and high performance and cache all this reflective metadata and annotation metadata. And the result is that you consume memory, and it's not possible to create a framework that both has low memory consumption and the features that developers love, like Spring, that are things like Spring Boot. But the thing is that I've had this question a lot. It's like from developers, is like, but why should we be more efficient? Who cares if it occupies a gigabyte of memory, my application? Does it really matter? So a question I tend to ask people is like, imagine if Kubernetes or Docker had been written in Spring or Jakarta EE instead of Go. Yeah. So both Kubernetes and Docker are essentially a collection of microservices. And you run them on your desktop, and your machine doesn't explode. Yeah. So if either of those things had been written in Spring or Jakarta EE, we would all need supercomputers for laptops to run them. Obviously, there are other reasons for choosing Go, the systems programming features and so forth. Absolutely, I agree with those. But one of the challenges that we face as a Java community is that we need to figure out how to build more efficient applications, because as a Java community, things like Go and Node and so forth, a lot of folks are selecting those over Java simply because it's more efficient, and in terms of cold starts, in terms of memory consumption, to use those tools than it is to use Java. And that's an unfortunate situation. And the situation is more down to the frameworks and the tools that we have today rather than any kind of language limitation with Java. And the thing is, all of these problems are already solved with something called ahead-of-time compilation. The Android community have already solved this problem. On Android, ahead-of-time compilation is used extensively. Any of you heard of Google Dagger? Yeah, so Dagger is a compile-time dependency injector that is completely reflection-free and computes all of your dependency injection model at compilation time, and that results in the increased startup time and lower memory consumption because you don't have to build all this reflective metadata and so forth. And the reason they built this is because on Android you have a more limited memory space. You know, you don't have you can't. It's not acceptable to use a gigabyte of memory in an Android application. Of course, Dagger is very cool, but it's kind of limited to just DI on purpose because they want it to be Android compatible. So it doesn't have many of the features that developers on the server side are familiar with, like AOP and all these other features. And that's where Micronaut comes in. So Micronaut is a new framework designed from the ground up with microservices. However, you don't have to use it just to build microservices. You can use it to build CLI applications. We have folks internally at OCI, the company I work for, using it to build Swing applications for some clients that we have. It's really a flexible framework that includes a whole bunch of things. But it just so happens that the characteristics that it has make it super nice to build low memory footprint microservices. It's ultra lightweight and reactive, so it features both an HTTP client and an HTTP server that are built on Netty. It uses ahead of time compilation, so instead of doing things like AOP and dependency injection at runtime using reflection, it's completely reflection free and computes everything at compilation time. And we have support for Java, Kotlin, and Groovy as language choices. We have a common AST across language implementations that you can visit the AST and write your own ahead-of-time compilation functionality. One example of that is we have support for Swagger, for example, that works for both Java, Kotlin, and Groovy by traversing the common language AST and pre-compiling your swagger.yaml file using ahead-of-time compilation. Like if you think about how most Java frameworks work that are not Micronaut, they compute your Swagger at runtime. Again, costing more memory, more resources, more, instead of doing all of that work at compilation time where it makes sense. So that's enough talk. Let's do a demo of Micronaut and see exactly what I'm talking about. So let's put a presentation mode here. So I have an application here. It's a Micronaut application. We have a command line utility that's optional, but it's nice to get going. You can create an app, and it's very fast to get going. Essentially, it's the similar model to Spring Boot and MicroProfile and these kind of things. You have an application class that has a main method, and you can run the application just from your IDE. And you can see that startup time completed in just over a second. In order to create, a good way to demo a new framework is, I find, is always Hello World. Developers know Hello World and are comfortable with Hello World. So what I'm going to do is I'm going to create a Hello controller. And it's going to be a controller that's going to map to the hello URI, and it's going to have a get method that's going to take a URI template with the name, and it's going to say hello name, and we're going to say hello name. There we go. So if I run this app now and I go to a browser, you'll see that hello. You can see that I've implemented Hello World. So how would I test this application? So I'm going to create a Hello controller test, and it's going to be a Micronaut test, and I'm going to create a JUnit test, JUnit 5, that tests my Hello World action. And what I'm going to do is I'm going to inject a client that is mapped to the root URI, and it's going to be an RX HTTP client, and I'm going to assert equals, use that one, hello John, client.toBlocking.retrieve hello, John. So that's like a basic unit test. See if that works, which it doesn't, because I have a capital H in my test. But you can see that the execution, one of the things that, look, the test executes in 407 milliseconds. So this is not like some pretend unit test. There's no mocking involved here. This is your real server starting, a real client being injected, and the test executes in 407 milliseconds. So this, in Java frameworks today, there is this artificial separation between functional tests and unit tests that we tend to put up with because our frameworks start so slowly. So people write fewer functional tests purely because it takes 10, 15, 20 seconds to start my application. So if I write a whole bunch of functional tests, suddenly I've got a build that's running, taking minutes to run instead. With Micronaut, it removes that separation because functional tests run as fast as unit tests. So that's a pretty trivial example, but what else can you do with Micronauts? So one of the things that you may want to do is you may want to instead return JSON. So what you can do is you can create a greeting class. We can have some text, and we can have a getter and setter. You can use Lombok as well if you want to remove some of the boilerplate. We have Lombok support. We can instead return a greeting. And it's going to be we're going to create a greeting here, equals new greeting. I'm going to set the text, and it's going to be hello name, and then we're going to return the greeting. Then in our test, we can come back here, and we can say I want to decode this as a greeting. And the text should be hello John. So now I'm using JSON interchange to communicate back and forth to my server, and just by returning a regular POJO. Now at the moment I'm using the kind of low-level client. So one of the nice features we have in Micronaut is you can create a hello client, which is an interface. And you can say that this client maps to the hello URI, and then you can say that you can define a get that takes the name, and you can define the greeting, string name, and then in my test what I can do is instead I can inject my hello client, and we can say hello client, hello, get text, and what happens with Micronaut is at compilation time. So most frameworks when you there are some frameworks like, I don't know if you heard of Netflix Feign, or there's some frameworks like this. What they do is they use runtime proxies and reflection to implement this behavior. So what Micronaut is doing instead is it's using a ahead of time compilation to implement the interface at compilation time so that the memory consumption stays low. It's just a regular class, and the JVM can inline it better and all sorts of things. So that's pretty cool. But obviously this is a blocking call, so that's not very nice. Reactive and all that stuff is the new trend. So what you can do is, instead return an RxJava single here, or a reactor mono, or whatever you prefer, anything that implements reactive streams. And now instead we can change this to blocking get, just for test, and we have a reactive client implementation. Now you can extract, if I extract variable, you'll see that the hello returns a single. You'll notice as well that we're kind of using the same annotations on the server as on the client. That's also by design. For example, one thing you can do is create a hello operations interface, and then you can make the hello client extend the hello operations interface, and you can pull this member up into the hello operations interface, override it if you so choose. You can then come into your controller, and you can say as well that this also implements the hello setting up a sort of contract. I see this now needs to return a single. We can make that happen too. There we go. And it's tempting to sign weaker access privileges. We don't want to do that. So now we have this common interface in between our two, both the controller and the client, which is pretty cool. Because we have the whole like metadata model, we can in terms of annotation metadata and everything, we can on the client, like for example, define retry policy, that it should retry 5 times. You can change this to circuit breaker as well. We have a circuit breaker annotation, so you can define on the client the number of retry attempts we have. We set this to 5, and because we have like annotation metadata computed into everything, right down to the configuration level, you can do things like say that this should be configured by my hello world client retry attempts property. And it should default to 5. And then if you specify hello world client retry attempts in your configuration, you can configure it the way, and it gets injected into your annotation metadata automatically for you. So you can control retries. Now typically you don't. This is looking up like a client based on the current server. This /hello syntax is like a shortcut for referencing the current server. But typically, you're going to want to, use service discovery and that kind of thing. So what you can do is, what I can do is I can say docker/run console to start up console, and then I can come into my configuration, and I'm going to set my server to have a random port so that I can have multiple of these, and I'm going to set my console.client.default.zone to my local host console. You'll notice that my Micronaut application.name is hello world. So what I can do is I can take that value, and I can in my client I can say this is a client for hello world, and the path is hello. So I've set up service discovery using console. We support Eureka. We support Kubernetes as well. So automatic service discovery. So now if I run this test again, what you'll see will happen is that we'll get an error saying something like it would help if I actually exposed my ports for Docker for console. Sorry. So when you run console, like any Docker thing, you have to expose the ports. And the other thing I'm going to do is, now I get an error that's saying no available service exception because it can't find any services. What I'm actually going to do in this test is you can configure the properties of the test, and I'm going to say console.client.registration enabled name value equals false. So I'm just going to disable registration so that my test itself doesn't register as a console client. We don't want that happening. And what I can do is I can run some instances of my applications. I'm going to run one. And actually, before I do that, I've forgotten to do a step. So what I'm going to do is I'm going to create a greeting service. And this, again, will let me demonstrate some of the dependency injection capabilities. So I'm just going to copy this just for demo purposes. So my hello message is going to be provided by my greeting service. And what I'm going to do is I'm going to inject the embedded server into my greeting service. So every Micronaut application has an embedded server instance bean, which you can access. And I'm going to say this is hello from embedded server.port. So I'm including the port number in my greeting service. And then in my controller, I'm going to inject my greeting service like this. And there it goes, using constructor injection. And I'm going to return greeting service.greet, or hello, sorry, name. There we go. So I'm injecting the greeting service. And now I'm going to run some instances of my application. So let's just stop any other instances that I may have running. And so I'm going to run one. So if I run one, you'll see that if I run my test now, and I do, if I run this test, you'll see that it's probably going to fail because that failed to inject value. So one of the things you need to remember, I need to declare this as a singleton bean. Micronaut doesn't know automatically what kind of bean this is. So stop this. Let's run it again. So if you just declare a normal class, it's not regarded as a bean. So now I'm going to run this test again. And what we have is a message. So now my failure is, hello John from port 18531. So I'm getting the right behavior back. If I were to do something like this, I'm going to create a second. So let's rename this single one. And let's create a second call called single2. Maybe you want to greet somebody else. And if we do single 2.blockingGet equals single 2. So let's try that test. We know it's going to fail, but this is just for demonstration purposes. So now we get, oops, it should be blocking get.text. So you can see that both responses are from the same port number, which is quite cool, because we only have one application running. And actually, if you wanna, you can go into localhost 8500 and check out your console, and you can see that I've only got one Hello World instance running and registered. What I can do now is come in here and run, a whole bunch more of my applications. I can run 4 or 5 or whatever number of applications I want. Notice that my laptop is not exploding as I'm running multiple Micronaut applications. And this is relatively archaic hardware, I think. And what I can do is run my test again. And you can see that each call, you get automatic round-robin load balancing between the two, the various active servers that are part of my service group. Yeah, so that's just out of the box, and it's completely configurable. If you want to plug in like Netflix Ribbon or some other kind of load balancing strategy, that's completely customizable, and it just works out of the box. Now, when you want to then eventually like take your application into production, you can, I'm going to stop console. You can, whether we support both Maven and Gradle, but in this case, you can assemble your application into a jar file. Actually, I shouldn't have stopped Docker. 8500. You can assemble your application. And then it's just a normal Java app. So you can say java/jar lib.hello-world to run your application, and it will register with console. Each instance of your application only occupies tens of megabytes of memory instead of hundreds of megabytes of memory. The actual war size of your application, so if we look at this, it's a 13 megabyte war. It's a bit bigger because we've got Hibernate validator. I blame Emmanuel, who's in the corner over there. It has a few extra features. So, but yeah, relatively small distribution size, and yeah, that's a little demo of Micronaut in action with Hello World. So controllers, clients, everything computed, compilation time from DI to AOP to everything that you expect from a modern framework. Smallest Hello World jar is 10 megabytes. You can run with as little as 10 megabyte of max heap. So I didn't demo that when I ran my application from locally, but you can say XMX 10 megabyte here, and the application will still start up and not throw an out of memory exception and still function and still register with console. You can limit it to a very small amount of memory and relatively, and it won't die. So all dependency injection, AOP, proxy generation, everything happens at compilation time. Micronaut will compute dependency and configuration injection, annotation metadata. So that's a huge one. All annotation metadata is computed at compilation time. You don't Micronaut doesn't have to, at runtime with reflection, traverse up your class hierarchy, your interfaces, figuring out what implements what is annotated with what. Everything happens at compilation time. All framework infrastructure. Basically, what Spring and CDI do at runtime, Micronaut does at compilation time. We like to think of Micronaut as a ahead-of-time compilation framework. Yeah, so a framework for building for computing application infrastructure ahead of time. So you may be thinking, yeah, not another framework, but Micronaut is, if we had just set out to build, I see new HTTP servers pop up every day on GitHub. It's like there's one after the other. Oh, look, there's another Java HTTP server. Oh, there's another Java HTTP server. That's not an interesting problem to solve. HTTP has been solved for a very long time. We're trying to solve a much harder problem here with Micronaut, which is to make Java applications way more efficient and way more consume way less memory. It does a heck of a lot than just being an HTTP server. It's a whole application framework, and it does a whole bunch of other stuff. We like to call it, the latest buzzword is cloud native. Well, we've gone one buzzword further, and we've called it natively cloud native. So it's built from the ground up to be cloud native. Yeah. And so from the very beginning, we built in service discovery with console, Eureka, Route 53, Kubernetes, configuration sharing with console and Amazon Parameter Store, just client-side load balancing. We got Hystrix support, we got Ribbon support for serverless computing, so you can write lambdas, you can write functions to deploy in OpenPaaS or FN, and we're going to use ahead-of-time compilation again to support Azure because they have a specific programming model for functions, which will again use the benefit of ahead-of-time compilation for that. And we have like in the examples repository for Micronaut, we have a nice like pet store application example, which has like different, about 6 or 7 different sub-projects, microservices. Each one is written in a different language, uses a different backend. Some of them use Neo4j, some of them use Mongo, some of them use Postgres. So I encourage you to check it out. It's pretty cool. I can spin it up with Docker Compose, and it starts up the whole Micronaut federation of applications fairly quickly. And it's basically a little pet store implementation, so I recommend that you check it out if you want a more comprehensive example that's beyond like just Hello World. This is what it looks like. It's like a pet store. It's eventually consistent, so it's saying could not load offers, but it will eventually be able to load the offers. And you can like go into a section of the site, and the cool thing is it kind of degrades gracefully. So you can see that I've got like a mail form here to request information about Ron, this dog. And what you can do things is like you can say Docker Compose pause mail. It will pause the mail service, and mail service is gone from the UI. Gradual degradation. You can unpause the mail service, and it pops up without me even refreshing the browser. using the front end is React, and it's reacting to the back ends being available or not available. So it's a pretty cool example of Micronaut in action. So do check out that that coolness. Like I said, serverless computing. So serverless computing is, again, so much about speed of cold starts, memory consumption. And as Java developers, we need to be so much more efficient in our framework choices to work with functions. And some of the options right now are like, you have to abandon DI, you have to abandon programming models that we like. Well, no, Micronaut, you can do DI, you can do all of the things that are that you need, that developers know and love, AOP, etc. And the impact on startup time is minimal. And that's the whole idea behind Micronaut, building a framework for the serverless era. And then speaking of ahead of time compilation, because Micronaut computes everything ahead of time, it has fantastic support for GraalVM. So what is GraalVM? It's a polyglot VM from Oracle that runs JavaScript, Java, Ruby, R, a whole bunch of things. It also has a really nice feature, which is the ability to turn Java code into a native image. Now, this GraalVM native only works under certain conditions, essentially. You need to be fairly careful in terms of using it. I must point out that GraalVM is at the experimental stage, and Micronaut's support for GraalVM is also evolving as GraalVM evolves. But it does work very well when there is little or no runtime reflection, limited or no dynamic class loading. You plan ahead so that you know that you're going to commit to using GraalVM, and you're going to use tools that work on GraalVM. And you use third-party libraries very selectively. So you can't use most ORMs. You have to use more low-level SQL. You have to be pretty selective about what you do. But the thing is that Micronaut checks a lot of these boxes already. So Micronaut has no runtime reflection. There is absolutely zero runtime reflection in a Micronaut application. We do all ahead-of-time compilation. So that has a lot of benefits in terms of being able to inline in the JIT, in terms of the size of your stack traces. No more method, java.lang.method that reflect stack traces like that on this big. Direct calls are the internals of Micronaut. And because of that, it works well with GraalVM because you don't have to tweak anything to get it working. Limited or no dynamic class loading. So GraalVM doesn't like it when you start to dynamically load classes and so forth. And we've done some really cool stuff with Micronaut to compute your class requirements ahead of time so that far less dynamic class loading is necessary in a Micronaut application. And like, for example, instead of doing class.forename, we have direct references to the actual classes in the bytecode when the application loads, and error handling if they're not there, and so forth. This means that GraalVM is able to deal with the Micronaut application because it has the direct references inside the bytecode. So the result is that Micronaut works really well on GraalVM. I want to leave time for questions, but basically what you do, and I have a little like hello world Graal application. Is we have a Docker file here, which comes as part of a Micronaut 1.0, and basically it specifies the GraalVM Docker images, and it computes your native image using Docker. So what you can basically do is Docker build dot and then give it a tag, say hello world, and it will it'll build your native image using Docker. This has a number of advantages. One of the advantages is that GraalVM doesn't have Windows support. So through Docker, you can build on Windows native images. And it has a number of other advantages. But basically, using Docker has some nice things that make it beneficial. It also means that it helps integrate into, if you're going to use like serverless platforms, a lot of them are based on containers. So the fact that it's already Docker enabled is cool. But basically, if I run this, it's going to take like 3 or 4 minutes to compute because the GraalVM compiler is anything but fast. Yeah, so I don't want to eat up 5 minutes of my presentation. But basically, what you can then do is say Docker run hello world, once you've computed the image. And you can see that Docker will run my application. That was actually one of the slow runs. It started up in 174 milliseconds, but probably because I have various processes running. But normally it's like 50 to 60 milliseconds startup, and like occupies about 20 megabyte of memory. Yeah, the application that is running on GraalVM. So GraalVM is pretty interesting. So like Graal itself, Micronauts support for Graal is at the experimental phase. I should probably rephrase that. Micronaut is not at the experimental phase. Micronaut is 1.0 now. Micronauts support for Graal is at the experimental phase. Micronauts ahead of time compilation and reflection-free model make it much easier to be Graal compatible. And a lot of things in Micronaut are already working on Graal. So we know that our stuff works on Graal. Third-party libraries is a bit hit and miss, but we already know that our HTTP server, our HTTP client, our serverless stuff, our service discovery, all of that, we already know that our DI and our AOP, it's all working on Graal already. We know it, we verified it, we have tests that show it, and so that's already a good start. Now, whether third-party libraries catch up, that's another situation. So Micronaut 1.0 is out. It's available on SDK Man. CLI is, you can install Micronaut with SDK, install Micronaut. It's also available on Homebrew, if you prefer Homebrew. It's available there as well. The CLI is not necessary to use Micronaut, but it's nice because you can just create projects and it's a bit of a convenience feature. Micronaut is just a standard Maven or Gradle build. Some resources around Micronaut. We have a Git community. Check it out there where you can ask questions and it's very active. We have a very comprehensive documentation. We've had a lot of people say, wow, what amazing documentation you have for 1.0. And we do. We have a load of documentation, a load of guides, the FAQ, the source code is there, the examples are there. We're already getting significant traction. We've been blown away by this response to Micronaut. It's really scratching an itch a lot of people have with Java applications consuming too much memory. And really, I think it's going to revolutionize how frameworks are designed for Java, how people think about framework design for Java. So there's a bunch of upcoming events, apart from this one, which you're already at. Check out that page. There's also a webinar. If you have colleagues, do tell them to sign up. You guys have already benefited from my talk, but if they want to hear more, if you want to convince colleagues, do send them to that link. There's an online webinar. I think it's on the 14th of November, so please do attend. So in summary, Micronaut aims to provide the same amazing wow factor for microservices that Grails did for monoliths 10 years ago. Now, over 10 years ago when I introduced Grails to people, they were blown away. We have 10 years experience building frameworks. We know how to do this. We know how to create a framework that is really compelling for microservices. And it's built by the people that made Grails. And we know the problems of framework development. We know how to resolve them. And we're doing it with Micronaut. So it uses ahead-of-time compilation to achieve what it does. Micronaut 1.0 is available now. And any questions? Yeah. Yeah, so I think the way it's the way the computation IntelliJ does the computation. This is relatively older hardware on the new computer I have at home. Micronaut starts up in about 700 milliseconds. It's also our bottleneck for startup time in Micronaut is class loading. Yeah. So if you run a suite of Micronaut tests, the first one takes like 700 milliseconds, but then the next one takes like 20 milliseconds because the class loading is already done. And I actually was working with the Google folks last week in San Francisco because there's something called, the IBM have an alternative JVM called J9, which allows shared class loading. And once you create a shared class loading cache with Micronaut startup time goes down to like 400 milliseconds, which is getting to node level like startup time without even having to think about using Graal or something like that. So I think we're already doing a fantastic job in optimizing as much as we can startup time, and a lot of our bottleneck is down to class loading on the JVM, which I think 1 second startup time is still good though. Yeah. So yeah, no technology comes without trade-offs. I'm not going to tell you that Micronaut doesn't have trade-offs, and the trade-off absolutely is in compilation time. So in compilation time, it's probably like 50% overhead, but like we've tested it on big projects, and it's about 50% longer. But you know, if you're doing microservices and you're doing functions, you're working with smaller multi-module projects anyway. And it only, in our testing, it only started to become problematic in terms of taking a long time when you had like 4,000 classes or something like that. So yeah, there's overhead at compilation time, but we believe the trade-off is worth it for what happens. Yeah. 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 Anyway, there's also improvements that we can be had in that area. Obviously, Micronaut is 1.0. I think I'm out of time. I am sure that there's stuff we can optimize. We have not maybe spent time optimizing the compiler. I'm sure we can make it better. So, yeah. Yes, I have to finish up, no? Yes, we have support for management metrics, micrometer, a whole bunch of stuff. Check out the docs. There's not enough time to do all of Micronaut. It's very comprehensive. Anyway, thank you very much.